Is section 4.7.1, which is talking about discriminants in the quadratic formula. Our EQ is how do I find the discriminant of a quadratic equation. Here's our new vocab for the day. What is a discriminant? How can I use the discriminant to describe the types of solutions? As promised, the warm-up is a quick little word problem. The height of a golf ball can be expressed by the equation y equals -0.001, whatever. And it says x is the distance traveled and y is height, both in yards. How far did the ball travel and what was the highest point that it reached? So if you think about a golf ball, this thing's going to start on the ground, go up, and then come back down. And we want to know what was the distance traveled and what is the height. So to start with, we want to find where is that axis of symmetry, which we know is an x coordinate. So to find the axis of symmetry, if we're in standard form, we know it's x equals the opposite of b over 2a. In this case, the opposite of b is -0.54. And if you do 2 times the a value, you get -0.0036. We type that into the calculator. -0.54 divided by -0.0036 gives me an answer of 150, which means that 100, now here's what's tricky. X equals 150 means that the horizontal distance that the ball traveled, this was 150 yards. So it took 150 yards of travel for it to hit its highest point, which means we know it must have traveled another 150 yards. So we can answer the second question right away. How far did the ball travel? The ball traveled 300 yards total. And then to find what is that maximum height that it reached, what was the highest it got, we would take 150 and plug that in for x. So in our calculator, we would say 150, store that as x, and then the equation was -0.0018, -0.0018 x squared plus 0.54x. Hit enter, we get 40.5. So that means that the ball got to a maximum height, the highest point was 40.5 yards above the ground. This is similar to the bridge problem from the quiz last week, but just kind of if you think of the ball as being a parabola, we want to start by finding the line of symmetry and then using that information to go from there. So that's just a quick little warm-up. Homework questions we're going to skip because you are doing this on your own. The big thing today, the new piece of information that we're talking about is the discriminant. And what the discriminant tells us is it tells us what types of solutions we have. We know, we talked yesterday about all equations that are x squared are going to have 2 solutions, and today we're going to see what we mean by different types of solutions. The big thing to calculate the discriminant, which starts with the letter D, is to do this right here. It's b squared minus 4ac, where a, b, and c are from the equation. So just like we had x equals -b over 2a, which was very important for the line of symmetry, the calculation for the discriminant is very important as well. So you have to write it down at the top of your notes, start, whatever you need to do. We're going to keep coming back to this d equals b squared minus 4ac. So there's that. What this looks like to find the discriminant. Here's how I like to set it up. We talked yesterday that The equation has to be equal to 0. This first example at least is equal to 0. So what I like to do is just on the side, what are my A, B, and C values? Well, A comes from the x squared, so A is 2, B is 8, and C is -5. The next thing I like to do is we're going to do 2 more calculations. What is B squared? What happens if you take the B value and square it? And what happens if you do A multiplied by C? So B squared would be 8 squared, so this is 64. A times C is 2 times -5, so that's -10. Then to find the discriminant, I have to do B squared minus 4AC, which for us now becomes 64 minus 4 times -10. Okay. Now the calculator, if you can type this in the calculator exactly as it looks, and we're going to just do that. So this would be 64 minus 4, and then in parentheses we put the AC value, which is -10. Hit enter, and we get 104. So that is the discriminant value, D equals 104. That is not a solution. 104 is not one of the 2 answers. We'll talk about in a little bit what a D value of 104 means. But right now, today, I want you to come out of the lesson being able to feel comfortable finding that discriminant value. For the second one, just like with factoring, the equation has to be equal to 0. So if it's not equal to 0, we need to make it equal 0. So we're going to start here by subtracting 25 from both sides. That gives me -3x squared plus 11x, and that becomes -16, I believe. And now we would do the same thing. What's my A? What's B? What's C? So those are in order: -3, +11, and -16. And then to make our life a little bit easier, we're going to figure out what is B squared and what is A times C. So B squared, B is 11, so that's 121. If I take -3 times -16, that is +48. So to find our discriminant value, we're going to do B squared minus 4AC, which is 121 minus 4 times AC, and AC was 48. Again, we're going to type it in exactly as it looks like that into the calculator. So 121 minus 4 times AC, which was 48. And we see that discriminant comes out to be -71. So the discriminant equals -71. Again, we'll talk briefly about what the discriminant value means, but for right now, I'm just concerned with being able to get the discriminant value for each one. So our first one was 104, the second one was -71. This is a sneak preview of tomorrow. The reason that we find the discriminant is because we're going to use what's called the quadratic formula. You may remember using the quadratic formula, you may not remember using the quadratic formula, but what's key here is that underneath the square root is all of this B squared minus 4AC nonsense, and that is exactly what we are calling the discriminant. So when we talk about this on Wednesday, I like to shorten this up to just say -b plus or minus the square root of the discriminant over 2a. And again, we know that they're the same thing because the discriminant is just b squared minus 4ac. So these two values are indeed the same thing. So we're not going to actually find the solutions today. We'll talk about that tomorrow. Okay. So here are the three different possibilities. if your discriminant, we know every equation that has x squared in it is going to have two solutions. Yesterday we looked at factoring, and all of those problems had two solutions in it. So if your discriminant is positive, any positive number, it could be 107, it could be anything positive. So it could be 107, it could be 3, it could be 6 million. The two solutions then are going to be real numbers. Okay. They might not be whole numbers, they might be decimals, but we know that they're both what we call real numbers, which is any number that you can think of that you would normally deal with. If the discriminant is 0, which does happen from time to time, the two solutions are actually going to be the same number repeated twice. What that means is, if you have a discriminant of 0, your two solutions might be positive 3 and positive 3 again. Or it could be negative 10 is one solution, and the other solution is negative 10 again. So we'll look at what happens. But for right now, just understand that if the discriminant is 0, we're going to have the same number or the same solution repeated twice. And finally, if your discriminant is negative, there are still two solutions, but those solutions are what we call imaginary numbers. And I'm going to introduce imaginary numbers today. It still uses the same number system that we think of, but it brings in some things that you haven't dealt with mathematically before. So if we have a negative discriminant, there will still be two solutions, but those solutions are going to be imaginary numbers. So again, if we try this real quick, to find the discriminant, I need to first subtract 9 from both sides here. So that equation is equal to 0. I get negative 2x squared minus 11x plus 6 equals 0. So my a value is negative 2, my b value is negative 11, my c value is 6. I can do those last two calculations of b squared and ac. Now you want to be careful here because the b value is negative 11, but I know if I take a negative number times another negative number, I'm still going to get positive 121. And then a times c, negative 2 times positive 6 is negative 12. So my discriminant then is going to be 121 minus 4 times ac, which is negative 12. 121 minus 4 times negative 12 is 169. Since that is positive, so d equals 169, that means my two solutions are both real numbers. Right now we are not finding what the solutions are, we are just determining are they real solutions or are they imaginary solutions. For this last one, I need to add 4 to both sides here, so add 4, 4x squared plus 1x minus 15 equals 0. So we got our a is 4, b is 1, c is negative 15. If I take b and square it, that gives me 1 still. If I do a times c, that is negative 60. So to find the discriminants, I would do b squared, which is just 1, minus 4 times ac, which is negative 60. We're going to type that in the calculator. 1 minus 4 times negative 60 I get 241. So that means the discriminant is 241. Because that is a positive number, I again know that there will be two real solutions. That doesn't mean that they're nice whole numbers, they could be decimals. But we know that both of the answers will be what we call real numbers. And again, we'll very briefly going to talk about what the idea behind what a real number is and what's an imaginary number. So, there's the discriminant. So that's kind of the first half of the lesson. That is separate from the second half of this lesson. We'll tie it all together on Wednesday, but just understand that half of your homework today is finding the discriminant. So that's kind of its own little category. And then we have this other category, which is simplifying square roots. So if you were to take the square root of 18 into the calculator, the square root of 18 is not a whole number. It is not even a nice decimal, 4.24, whatever. What we're going to do in this chapter is we are not going to put decimals. When you have square root of 18, a number whose square root is not a whole number, we are not going to call that 4.24. All we're going to do is try to simplify it. And what I mean by that is I can split up a square root into two different square roots, but I'm only going to do this as long as one of these numbers, first of all, it has to go into 18, and it has to be a number whose square root is a whole number. So if you think of the values that we know the square root of, we know the square root of 4 is 2, the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and so on. So the question is, do 4 or 9 or 16 or 25, do any of those go into 18? And it does. You shouldn't have to look too long to know that 9 goes into 18 two times. So I can break the square root of 18 into the square root of 9 times the square root of 2. Now, we know the square root of 9 is just 3. So I'm going to write the number 3 without the square root symbol. And then the square root of 2 cannot be simplified. Right, we know the square root of 4 is 2, but the square root of 2 is not a whole number. So the square root of 18, we are just simply going to call 3 times the square root of 2. And sure enough, if we go to the calculator and I type in 3 square root 2, I'll still get that same decimal. So they are equivalent, they are saying the same thing, but we want that number inside, underneath the square root symbol, we want that number to be as small as possible. So we look at square root of 75. Square root of 75 is not a whole number. I know the square root of 64, and I know the square root of 81, but the square root of 75 does not work. So I want to see, is there a number that goes into 75 that I know the square root of? And we see that 25 goes into 75 3 times. Square root of 25 is 5. Square root of 3, I can't simplify it all, so 5 times the square root of 3 is the same as square root of 75. And then finally here, 180 can be tricky. You might recognize that 9 goes in to 180. And if you check in the calculator, 9 times 20 is 180. So this would become 3 times the square root of 20. But then we can actually break down the square root of 20 even further, because 4 does go into 20, and that is a perfect square number. I'm going to bring this 3 down. And then here we have 3 times the square root of 4 becomes 3 times 2 times the square root of 5, which is 6 square root of 5. And 5 can't be broken down any further, so you would break the square root of 180 all the way down into 6 times the square root of 5. And again, if we go check in the calculator real quick, the square root of 180 is the same as 6 times the square root of 5. So you might be saying to yourself, what's the point of doing this? This doesn't make any sense. Again, right now it's kind of, you're taking two individual skills between the discriminant and square roots, and it's going to all come together tomorrow. Okay. So if we look, this would be the U try, but if we look at the square root of 8, 4 goes into 8, so we would just break this up into square root of 4 and the square root of 2. That would then be 2 times the square root of 2, because the square root of 4 is just 2. So that's that. And then the square root of 125, we would break, the number 25 goes into 125 5 times. I know the square root of 25 is just regular 5. And the square root of the number 5 is not a whole number, so we keep that underneath the square root, and this would be our simplified version. So, as you work through today, just keep in mind 4, 9, 16, 25, all of the numbers that you know the square root of. And then finally, we're going to kind of mesh the two together real quick that we've talked about today. And we're going to talk about what happens if you take a negative square root, or what happens if you take the square root of a negative number. This is where the calculators don't work. If you try to type in the square root of -9, it says it is a non-real answer. You'll notice it doesn't say it doesn't exist, it just says non-real. So what mathematicians and what math people do to show this, the reason that this doesn't work is because you can't square root any whole number, at least the way that we think of this. We know the square root of 9 is +3 and also -3 based on what we talked about yesterday. So if you see the square root of -9, this is the key, is that we are going to use the letter I for imaginary to stand for the square root of -1. What that allows us to do is that allows us to break the square root of -9 into the square root of a number that we know and the square root of -1. So the square root of 9 is 3. If you see the square root of -1, we are just going to represent that with the letter I. So the square root of -9, we are actually going to call 3i. You'll notice that it's basically the same as this. The only difference is that negative that was with the 9 results in us putting an I with the square root. So just like the square root of -25, we would call 5i. Okay. So again, just kind of how this looks. You type in the square root of 49 in the calculator. We all know that it's 7. The square root of -49, we would call 7i. Because we're trying to square root a negative, which we can't do with the real numbers. That's why we use these imaginary numbers and the letter I. And then here, we do want to be cautious with this. Because the number that's being square rooted is just 49, which we know this is 7. And then we're going to take the negative and apply it to that. So the negative square root of 49 would just be -7. We do not use I for this problem. You would just put the negative sign out front. So, if you see a negative underneath the square root, we're going to use I. So here's what this looks like. Same sort of thing. If you are simplifying a negative square root, we're going to look for, again, a number that goes into, so for instance, the square root of -8. I want a number that goes into 8 that I know the square root of. And since we know the square root of 4, we're going to break this up. But I'm going to include the negative sign with the 4 If I do that, I have -4 and +2. I don't know what the square root of 2 is, so that's going to stay the same there. But we know the square root of -4. We are calling that now with these imaginary numbers. We're going to call that 2i. So this is actually our final simplification, is 2i root 2. Same sort of thing if we take a look at square root of -24. Again, 4 goes in to 24. So we're going to take square root of -4 and the square root of +6, which I don't know, the square root of 6. So this becomes 2i root 6. 6 cannot be broken down further because 4 doesn't go into 6. And then 9, 16, obviously numbers that are greater than 6 won't work. So that's just 2i root 6. And finally here, -125 can be broken up into -25 and +5. The square root of -25, again, because it's a negative, we're going to use I. So that would be 5i. And then we leave that with 5. So anytime you have a negative number underneath the square root, when you are simplifying it, you will use I to show that it is an imaginary number, meaning it does not work in the traditional sense of no calculator will square root a -40. Last thing I wanted to take a look at is, so the square root of 45, don't just assume that you need to use I. Since this is a +45, we will not use I at all. What we look for, is there a number that goes into 45 that we know the square root of? Sure enough, 9 goes in. 9 times 5 is 45. Square root of 9 is 3, so that's just 3 square root 5. That's how we would simplify that. And then the square root of -300. I know 100 goes in to 300. So 100 times 3 would give me +300. But since I know the square root of 100 to be 10, that is where I'm going to keep the negative sign. Square root of -100 would be 10i. And then the square root of 3 I can't do anything with, so we keep it just like that. So that'll be 10i root 3. I understand these two topics seem kind of disconnected and don't make a whole lot of sense. But again, this will come back around to make sense tomorrow, hopefully, on Wednesday. So your homework is a Schoology worksheet. It's called Discriminants and Simplifying Square Roots. It's exactly as it says. About the first half is finding the discriminant and deciding does the equation have 2 real solutions, 2 imaginary solutions, or is it the same number repeated twice? And then the second half of the homework is just simplifying these square roots. So hopefully you enjoyed your time here at Lucan Academy, or whatever you want to call this, and I am out.